The modern network has 4 things to be expected of it: hierarchy, modularity, resiliency, and flexibility. Hierarchy allows every device on every level to serve a purpose. Modularity allows the network to expand easily. Resiliency allows constant availability of the network, and flexibility allows the most efficient use of the systems. When all of these traits are achieved, you have created a borderless network, moving beyond older networks and allowing a flexible network that enables expansion, availability, and efficient use of the systems in place. A truly borderless infrastructure has 3 layers: access, distribution, and core. Access represents the edge of the network, where traffic comes in and leaves. This gives end users the access that they need. This layer connects directly to the distribution layer. The distribution layer works between the access layer and the core layer. This is where switching, routing, and other network devices work to provide various services for your network. The core connects all the distribution layers together. Sometimes the collapsed and distribution core are combined together. This is called a collapsed core. So what is a switched network? A switched network allows all sorts of logical controls to add increased quality of service, better security, support for wireless networks, increased speed, and better expansion. There are many different types of switches when trying to pick a switch for your network. Cost, the amount of ports, PoE support, port speed, frame speed, and scalability might be very important to you. There are 3 different kinds of switches. Fixed configuration. These switches limit you to exactly what comes with it with no forms of modularity, meaning you cannot expand the switch. Modular configuration. These switches give you many different ways to customize, but are very expensive. Stackable configuration. These switches can be connected together to operate as one large switch. So how does switching work? Well, switches send something called frames. These work on layer 2. When hosts send a frame, it is received by the switch. The switch will check something called the MAC address table. If it does not have the source MAC address of the host, it will record it and add it onto the table along with the port number. From there, the switch will examine the destination MAC address. Be aware that Cisco switches will forward frames based off the destination MAC address. If it doesn't find the destination MAC address, the switch will flood a broadcast through every port except for the one where the frame came from. When the device that has the destination MAC address receives the frame, it will notice and receive the rest of the frame. Keep in mind, if this frame is forwarded to other switches, those other switches will also record the source MAC address and the port. Forwarding of these frames usually ends after they hit the router, because it interacts with a different layer. Cisco switches have 2 ways of forwarding frames: store and forward, and cut through. Store and forward will store the entire frame, compute something called the CRC, and if the CRC check approves, the switch will look up the destination address and send the frame to the correct port. Frames that do not pass will be dropped. This method allows switches to find errors using something called the frame check sequence and allows mixed Ethernet speeds with automatic buffering. Cut-through switching will forward the frame after it reads the destination address. Because of this, cut-through might forward invalid frames, which can impact bandwidth and network performance. Cut-through has an additional forwarding method called fragment-free switching, which allows the frame to be checked to ensure that there is no fragmentation, making it better at checking for errors. Invalid frames are dropped with fragment-free switching. Within a switched network are collision domains. A collision domain is a network segment where packet collision can occur. With hubs, data transfers are done in turns. This is called half-duplex. Everything connected to the hub is a part of a collision domain, meaning data cannot move through the network efficiently. Everything is relatively inefficient, and it can lead to security risks and lost performance. With switches, every link has its own collision domain, and by default, communication is in full duplex mode compared to the half-duplex mode. which means that both sides can send and receive data, and neither side has to wait, like with a half-duplex. A switch giving each port its own collision domain is also known as microsegmentation. Like collision domains, we need to talk about broadcast domains for just a second. Broadcast domains are dependent on the network. Like how every individual communication link has its own collision domain, broadcast domains are based entirely on the network itself. If we had two different networks on two different switches, connected together by one router, there would be two broadcast domains if we took a close look. And if we took a closer look, we would see that the switch gives two broadcast domains. That's it for this episode. In the next one, we're going to be talking about the command line interface and configuring switches.